Good morning, ma. So last class we explained matrices concept. So in that concept, some three definitions there. Today we completed the definition and that continuous concept, determinant concept also. Today we completed. Tomorrow and day after tomorrow we will explain the questions. So previous case set bits on matrices and determinants. Okay. So right. So yesterday continuation part. Yesterday continuation part there. So now we can learn there transpose of a matrix. That is also very important. Transpose of a matrix. Transpose of a matrix. Transpose of a matrix. So this is simple, nothing but. So now we can consider one matrix A is equal to here A, B, C, D. So this is the 2 by 2 matrix. What is transpose of a matrix means? In any matrix, we can interchange rows into columns or columns into rows. Rows into columns or columns into rows. Then the resulting matrix or obtained matrix is called a transpose of the given matrix. Now this is A is equal to A, B, C, D is the 2 by 2 matrix. Now this is a transpose if you want to write down. Then what we write down here? We can interchange rows into columns or columns into rows. Now we can interchange. So rows means already yesterday I told them. So rows means what? Horizontal lines or rows are counted from top to bottom. Columns means vertical lines. Columns are counted from left to right. So now we can change this row in terms of column means A, B. This one what? C, D. Now this is the resulted matrix or obtained matrix of the given. Now this is called transpose of the given matrix. Transpose we can represent with A dash or A power T. A dash or A power T. So these are the two symbols for transpose of a matrix. So we remember transpose of the transpose of the matrix means in the given matrix we can interchange rows into columns or columns into rows. Then the resulted matrix or obtained matrix is called a transpose of the given matrix. Here important points there are properties of the transpose of matrix. So first we can write down here A dash whole dash. A dash whole dash is nothing but A value. Now this is the transpose. Again we can apply the transpose of in this matrix. That rows can be converted into column rows can be converted into column. Again if you are getting the same matrix. So that's why A transpose whole dash is equal to A dash value. Now we can write down here A plus or minus B whole dash or whole transpose is equal to A transpose plus or minus B transpose. We can separate the two values A plus B whole transpose. A transpose plus B transpose. A minus B whole transpose is equal to A transpose minus B transpose value. Okay, na? Right. Here next AB whole transpose is equal to B transpose into A transpose. B transpose into A transpose. Whenever we can apply the product form, then we can separate that product. We can run first B transpose into A transpose. A plus or minus B, B transpose. Now another point here, we can multiply any constant K into A whole transpose is equal to constant value into that matrix transpose K into A transpose. Now we can write on here whenever two matrices are equal. Matrices are equal. Matrices are equal means yesterday we discussed the concept that two matrices have the same order and the corresponding elements are same. Now when two matrices are equal, their transposes are also equal. Their transpose is also equal. So this is also important concept. In that concept also they given JE and K set bits also given. So now we can remember these conditions. So transpose of any matrix is nothing but we can interchange rows into columns or columns into rows. Then the resulting matrix or obtained matrix is called a transpose of the given matrix. Transpose can be represented with the two symbols, A power T or A dash value. A power T or A dash value. Okay, now A power T or A dash value. Now A transpose whole transpose is equal to A. A plus or minus B whole transpose is equal to A transpose plus or minus B transpose. AB whole transpose is equal to B transpose into A transpose. And this is the properties of the transpose of a matrix. So next another definition important for this one. So symmetric and skew symmetric. First one, symmetric. Symmetric matrix. Symmetric matrix. Here definition ma, a square matrix must and should we can represent a square matrix is said to be symmetric. A square matrix. A square matrix is said to be symmetric. Is said to be symmetric if A transpose is equal to A value. So any square matrix is said to be symmetric matrix. Then what we have done here? A transpose is equal to A value. Okay, now general elements condition here. Aij we can choose that value is equal to Aji. Aji. So that value is equal to how much means Aji. Okay, Aji. This value is Aj. So element. Now here standard form of symmetric matrix we can consider here. A is equal to matrix. A is equal to A H G, next H B F, next G F C. So this is the standard form of a symmetric matrix. Now we can applying the transpose of this matrix again if we get the same matrix. Now see my here what we are done here. A transpose is equal to, we can interchange rows into columns. So this is the row. So this first row can be written as column A H G. Second row means H B F. Third row means G, F, C. So now this is the same to given matrix. That's why A transpose is equal to A means this matrix is said to be symmetric matrix. So this is the standard form of symmetric matrix. Standard form of a symmetric matrix. Elements Aij is equal to Aj value. Okay, now another definition there. A square matrix is said to be skew symmetric. Here what we are done? Skew symmetric matrix if A transpose is equal to minus A value. A transpose is equal to minus A. Here elements also Aij is equal to minus Aij. Aij is equal to minus Aij. But we can consider here standard form of the skew symmetric matrix. A is equal to skew symmetric matrix, standard form of skew symmetric matrix. A is equal to 0 H G minus H 0 F minus G minus F 0. So this is the standard form of skew symmetric matrix. Another point we remember, whenever the principal diagonal all elements must be 0 in the skew symmetric matrix. Skew symmetric matrix, the principal diagonal must be zeros, and we can take the signs. Here element H there means opposite side. Here G there means minus G. Here F means minus F. Or here below the principal diagonal elements are positive, above the principal diagonal elements are negative. That is also standard form of the skew symmetric matrix. Opposite signs of the element, the principal diagonal elements must be zeros. So such type of matrix is said to be skew symmetric matrix. A dash is equal to minus A value. A transpose is equal to minus A. Then that matrix is said to be skew symmetric matrix. Any matrix that values, for example, they given in exams like this also they given. Sometimes he given here. Sometimes they given value here. So B given. B here what given in this matrix B given. So the given question, if A is equal to skew symmetric matrix and A can be represented like this, what is the value of B? What is the value of B? So we know that in any skew symmetric matrix, the principal diagonal elements are must be zeros. That's why that value must be how much here? This value we can consider 0 value. That is very, very important. So skew symmetric matrix, that means that principal diagonal elements must be 0. Principal diagonal above elements are positive means below elements are negative. Below elements are negative means above elements are positive. Opposite signs them. So this is the symmetric and skew symmetric matrix. Okay, now we can remember one point. A matrix is both satisfy symmetric and skew symmetric. A matrix is satisfy both symmetric and skew symmetric. At the time that matrix is a diagonal matrix. Sorry, that matrix is a null matrix. Means, for example, A is symmetric. A is symmetric means what would have done? A transpose is equal to A value. A is skew symmetric. A transpose is equal to minus A value. So they given a square matrix is represent both symmetric and skew symmetric at a time. What is the A matrix? Now A is symmetric means A transpose is equal to A. Skew symmetric means A transpose is equal to minus A. Now from these two equation, left side are equal. So automatically equating to the right side of the parts. Then that A transferred to this side, this value can be written as 2A into 0. Then what we can write on my here? A is equal to 0. So that's why A is which type of matrix? Null matrix. When we can consider that null matrix, A is both symmetric and skew symmetric. At the time that matrix is said to be null matrix. Okay. Now another point there in board also, any square matrix they given, that matrix can be represented as a sum of the symmetric and skew symmetric part. That is also important for case set. So they given any one matrix given capital A. So this matrix can be represented as a symmetric and skew symmetric part. Then what would happen here? Half into A plus A dash or A transpose plus half into A minus A dash. We can add these two value again if you are getting same matrix. Okay, so now this part, then this part, which part? This one, half into A plus A transpose is called a symmetric part. This part is called what? Symmetric part. This part is called symmetric part. So what about this part is called skew symmetric part? This part is called symmetric skew symmetric part. Okay, na? This is also important. In previous CET case bits, they ask the question, one matrix given, what is the part of skew symmetric, what is the part of symmetric? Then we can consider symmetric part means half into A plus A dash, skew symmetric part means half into A minus A dash. Okay, na? So now this is the concept on matrices, and some bits also there, symmetric and skew symmetric matrix. One example given for case set previous bit, that one. So they given this type of questions given. So which type of questions they asking in a case set means A comma B are symmetric. A and B are symmetric matrix. Symmetric matrix. What about A plus or minus B or AB minus BA? AB minus BA. AB minus BA. So what is the value of this one? Value is nothing but symmetric, skew symmetric. So this type of models also important. Whenever they given this type of questions, A comma B are symmetric. Already we know that symmetric. So what is symmetric means? A is symmetric means A transpose is equal to A value. B is symmetric means B transpose is equal to B value. Now we can find out. Suppose one example I given here, A plus B whole transpose. Now this one you have to show that symmetric or skew symmetric. The property then transpose. A plus or minus B whole transpose is equal to A transpose plus B transpose. Now we can write on here A transpose plus B transpose. In place of A transpose, we can write on A value. In place of B transpose, we can write on B value. Now here, Sima, for example, now we consider here for your understanding purpose. So this is P value. A plus B is equal to how much? P. Now what we done here? P transpose is equal to P value. Now we can choose one matrix. That transpose is equal to same matrix. At the time, P is called symmetric. P is nothing but A plus B. A plus B is which type of matrix? Symmetric matrix. And similarly, we can consider A minus B. Also same. AB minus BA is also, we can apply that property. Now we can apply this question, Sima, here. AB minus BA. Now whenever question we remember, so they given question symmetric or skew symmetric, any part, we can apply the transpose for the both the whole. Now we can apply the transpose of this one. AB minus BA whole transpose can be written as AB whole transpose minus BA whole transpose. Already I given that properties. So AB whole transpose can be written ulta, means reverse. B transpose into A transpose. B transpose into A transpose minus A transpose into B transpose. B transpose is nothing but B value. A transpose is nothing but A value, and again AB. But if you can choose the value AB minus BA, but the given value BA minus, so this is not satisfied. we can take one minus common. Again, what put on this value? AB minus BA. Previously, I took the value AB plus B is equal to P. Similarly, here also we can consider AB minus BA is also P. P transpose is equal to minus P. P transpose is equal to minus P. Then what about we say that P transpose is equal to minus P means we can write out that matrix is a skew symmetric matrix. P is skew symmetric means AB minus BA is also skew symmetric. Okay, understood? So right, this is very very important concept for case set. Okay, now this symmetric part and skew symmetric part transpose symmetric. Okay, right. So now we can start the continuation concept of determinants. Today I will explain that total concept of determinants. Tomorrow and day after tomorrow, two sessions there. In the two sessions we explain that questions. Okay, right. Sima, now we can discuss that determinant. Determinant or determinants. Okay, so determinant. So what is a determinant? What is the difference between matrix and a determinant? Determinant is always given some number given. So matrix given some information given. Matrix given always some information given. So determinants given one real number given. So that's why how do we define the determinant of a square matrix? The determinant of a square matrix A is equal to A B C D. A is equal to A B C D. The determinant of a square matrix 2 by 2 order. The determinant of a square matrix capital A is equal to A B C D. Then the number. Then the unique number. Unique means only one. Unique number is AD is AD is AD is what more here? AD minus BC. So this value is called AD minus BC is called determinant of the given matrix. Determinant of the given matrix. So that's why I told them determinant means is a number. Determinant means a number. That number is also same. For each determinant having only one value only. Now A is equal to A, B, C, D. The unique number, then the unique number of this matrix is called the determinant AD minus BA value. AD minus BA value. So how to define the determinant? This determinant is denoted with DET, det A, or we can write on this one modulus type, but we can pronounce this one determinant of A or det A. Then another one, which matrix given? That matrix elements can be represent inside of this vertical lines. Then this is also called a determinant of a matrix. Okay, so what is the determinant of the matrix? Means the determinant of a matrix capital A is equal to A, B, C, D given. Then the unique number, AD minus BC. How to calculate SIMA? 2 by 2 matrix given means, for example, we take the positions 1, 2, 3, 4. We can consider 1, 2, 3, 4. Now we can take the cross multiplication of these number 1 into 4 minus 2 into 3. 1 into 4 minus 2 into 3. Then this number, this value is called a determinant of the given matrix. For example, now we can take one matrix A is equal to 2, 3, 5, 7. 2, 3, 5, 7. What is the determinant of this matrix? Det A is equal to, we can multiply first and fourth position elements, means 2 into 7. 2 into 7 minus second and third position 3 into 5. This value what more? 3 into 5. This value is equal to 14. This value is equal to 15 minus 1. So this is the determinant of the given matrix of order 2 by 2. Okay. So det A or determinant of A, or like that we can represent two vertical lines in between. You can run that elements of the given matrix. That is also called determinant of A value. Okay. So that is the determinant of 2 by 2 matrix. Next, another definition, minor of matrix. Minors of matrix, minors of a given matrix. Now here I took 3 by 3 matrix. Then For example, we can take first example we run. After then we can understand this value A11, A12, A13. Next A21, A22, A23, A31, A32, A33. Okay. Already I told them that positions means A here A1 3. Okay na? So this is the 3 by 3 matrix. Now we can find out the minus of the given matrix elements, minus of elements in the given matrix. Now we can find out this minor can be represented with M11, but that meaning M11 meaning which element we can prove. So first row and first column, element means this is nothing but this one. A11 minor if you want means, listen, A11 A11 minor if you want means which element we can consider, that corresponding row we neglected or we deleted that corresponding row and corresponding column. We can take remaining elements as a one determinant, 2 by 2 determinant means, for example, this is the corresponding row and this is the corresponding column. We neglected that elements and this element, remaining only we can write on means A22, A23, A32, A33. This determinant value is called minor of M11, means minor of A11. Okay, minor of A11. Simply remember, minor means which element we can consider in the given matrix, that corresponding row and column or we neglected means or we deleted. Deleted means neglected in your mind. So now we can take remaining 4 elements in 3 by 3 matrix. In 2 by 2 matrix means only one element. That determinant value is called minor of the given matrix M11. Now I can choose the minor of A32. A32. Where is A32? This one. So that corresponding row and column means the last one and middle one. We accept that values. Then what we run here? A11, A13, A21, next A23. So this is the minor of the given elements of the matrix. Okay, understood? So which element we can choose, that corresponding row and corresponding columns are neglected. Remaining elements we can write on one determinant, that is called minor of the given matrix. Or if you have any doubt, so 2 by 2 given, how to we can write on that minus? Nothing, same 1, 2, 4, 5 elements there. 1, 2, 4, 5. Now we can find out the minor of 1. Minor of 1 means M11 means this one we consider means the corresponding row and corresponding columns are neglected. Remaining one element, which number that number. Here determinant also we consider, but that number only we can. Any singleton matrix determinant, that same number only given. Determinant of the singleton matrix is the same number only given. Next, M12 means what? M12 means first row and second column. 2 corresponding opposite number. M13, sorry, M12, this one 4 corresponding 2 value. M22 is 1 value. So these are the minors of the 2 by 2 matrix and 3 by 3 matrix. Next, after then this one, another definition there, cofactor. So what is cofactor? Here only explain that cofactors of an elements in matrix. Cofactor. Okay. So cofactors. So how to define cofactors, Sima here? Cofactor is nothing but, first we can find out the minors. That minors are multiplied with, minus 1. For example, cofactors are denoted with Aij is equal to minus 1 whole power I plus j. This value multiplied with the minus. The given minor is multiplied with minus 1 whole power I plus j. That resulted value is called the cofactor of the given elements. Cofactor of the given element. Now here, Sima. So this is the M11. Now what is A11? Here this value can multiplied with the I power A plus minus 1 power I plus j. I is means what? That row position. J means what? That element column position. That can be read on here. Then we can find out this cofactor. Cofactor means what? Minor multiplied with minus 1 whole power I plus j. That value is called the cofactor of the given matrix. For example, we can take one matrix here. Now, Sima, both now explained in this concept. 1, 2, 3, 4, 5, 6, 0, 1, 3 there. sorry, if you are getting confusion means again it is the -1 -3. Now first, now we can find out the minor of two element. What is minor of two element? M12, first row and second column. What I told me here, which element we consider? That corresponding column, corresponding row we neglected. Means this one and this one is neglected. Remaining four elements, what here? 4, 6, 0, -3. This is the minor. Already we know the determinant of 2 by 2. How to calculate? 1 into 4 minus 2 into 3. Now this value is equal to -12. This value is 0. That this value is equal to -12. This is the minor of two element. Now I want to find out cofactor. A12 is equal to M12 into -1 whole power I plus j. -1 whole power I plus j. So now we can write on here M12. M12 means value how much here? -12 into -1 whole power I plus j. See, my I means here 1, j means 2. First row and second column. So that's why what we done here? 1 plus 2 value. 1 plus 2. So that is equal to what we done here? -12 into this value -1 whole cube is nothing but minus. Minus into -1 plus 12. So this is the cofactor of the given element of true value. So this is very important. Why? In board also they given 5 marks questions given, and competitive CET also they given inverse question given 3 by 3 matrix. But we are applying the shortcut method here for 3 by 3 matrix. In board we can find out the lengthy process. So except that one, we can apply the shortcut method and we can find out this one. So this one understood, minor and cofactor. Minor means which element we can choose, that corresponding row and column are neglected. Then the remaining value is multiplied with -1 I plus j. That value is called the cofactor. A12 is the cofactor of M12. Okay, na? Right. Next. So this is the minor and cofactor and a determinant over. Next, after them 3 by 3 determinant they given. How to define 3 by 3 determinant means A is equal to, with example we consider means 1, 2, 3, 4, 5, 6, 7, 8, 9. Now can calculate this determinant value. So with example I explain this one. So determinant of 3 by 3 matrix means the sum of the elements in row or column. We can choose any one, row or column. The sum of the elements in row or column multiplied sum of the product of elements, in row or column multiplied their corresponding cofactors, The total value is called the determinant of 3 by 3 matrix. For example, now I can choose the value 1. So one element we consider means first minor multiplied with, so directly we write on in board also. What we write on first, we consider this one, neglected that row and column. What we write on here? 5, 6, 8, 9. So this is the cofactor of one element. Next, in determinant expansion, must and should be written minus always. So why you written minus means here actually we can take plus only, but that element 2 there number 2, and that corresponding cofactor means 4, 6, 7, 9. But this is only minor. This minor is multiplied with -1 whole power I plus j. This position, what here? 2 position, first one, third column. First one, second column means odd number power. So that's why instead of this plus, what we write here means minus. Always we can write on minus. That is change that cofactor. Next, plus 3 into here Sima, plus 3 into again what we run 3 minor means 4, 5, 7, 8. 4, 5, 7, 8. So this is the determinant of 3 by 3 definition. Determinant of 3 by 3 means we can choose any row or any column. That row element or column element, sum of the product, this is the sum of product of that corresponding element multiplied their corresponding cofactors. 1 multiplied their corresponding cofactor, 2 multiplied their corresponding cofactor, 3 multiplied their corresponding cofactor. That value is equal to determinant of it. But another one property we remember, whenever we can take row 1 elements, but we multiplied with the row 3 cofactors. So row 1 elements multiplied with the row 2 cofactor. Other row cofactors at the time that value is equal to 0. That value is equal to 0. That is also important property. Means here determinant of A when becomes 0 means any row element multiplied their another row cofactor, not corresponding cofactor. At that time the determinant value is equal to 0. So these are the 3 by 3 determinant conditions. Here some properties then, this property is also very very important. So first property what means, we can take any one determinant. In the determinant 2 4 6 2 4 6 3 2 4 6 3 7 8 7 8 4 8 12 2 4 6 3 7 8 4 8 12. See ma, here first row, this is what here, this is the first row and this is the second row, this is the third row. Now here what we are observing means, in the determinant first row and third row are the same proportional. 4 by 8 is equal to 6 by 12. Value how much more? This value 1 by 2, this value 1 by 2, this value 1 by 2. So whenever any two rows or columns are identical, same or same proportional, at the time that value is equal to 0. In any determinant, two rows or two columns, any two rows or any two columns are identical, means same number or in proportional or in the ratio is same. At the time the determinant value equal to 0. Without calculation we can write on 0. Without calculation we can write on 0. Okay na. Next another point ma, if we take any one determinant, row wise or column wise elements are 0, remaining different any value they given, but that value is equal to how much? 0. In any determinant, any row or column elements are 0, then the total determinant value is also 0. Here Sima, in this determinant property, any determinant two rows or two columns are identical, same irbodu, illa andre same proportional irbodu, at the time that value is equal to 0. Next, so another important property, now in this determinant, for example, now we can take one example 1 2 3 4. Okay na? Now what is the det value of this one? Det A is equal to, we can add on 4 minus 6 minus 2. Now we can take same determinant only, but compared to A determinant, row 1 we multiplied with some 4 number, 4 8, 4 ones are 4 2, only multiplied with row 1 only. Then the resulted determinant value, Sima, det B is equal to 16 minus 24, means value how much more? Minus 8. Previous minus 2 there, here how much there? Minus 8 there. So minus 8 can be written as 4 into minus 2. So here property what means, we can take any one determinant, that determinant any row or column we multiplied with any number k, that the resulted matrix original determinant value is also multiplied with k times. Here to minus 2 there, here 4 into minus 2 ಅಂದ್ರೆ ಏನ್ ಮಾಡಿದನ ನಾನು ಫಸ್ಟ್ ರೋ 4 ಜೊತೆಗೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರು, ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ resulted matrix determinant value 4 times of the original determinant value to 4 times ಆಗುತ್ತೆ, ಅದು k times ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆನಾ. ಸೊ ದಟ್ ಇಸ್ ದ ಅನದರ್ ಪ್ರಾಪರ್ಟಿ. ನೆಕ್ಸ್ಟ್, ಮುಂಚೆ ನಾನು ಒಂದು ಪ್ರಾಪರ್ಟಿ ಹೇಳಿದೆ, ಏನ್ ಹೇಳಿದ್ರಮ್ಮ, ಇನ್ ಎನಿ determinant, any determinant, any row or column elements are multiplied with other row corresponding cofactors, at the time the determinant value equal to 0. Okay na. So another property ma, in any determinant of a square matrix, suppose for example a1 plus x, a2 plus y, a3 plus z there, here b1 b2 b3, this one ma, c1 c2 c3 ma, in any square matrix determinant any row or column can be expressed as the sum of the two number, then the determinant can be expressed as the determinant of sum of the determinants of two square of the same order. ಅಂದ್ರೆ ಏನ್ ಗೊತ್ತಮ್ಮ, ಇವಾಗ ರೋ ಅಲ್ಲಿ ಆಗ್ಬೋದು ಕಾಲಮ್ ಅಲ್ಲಿ ಆಗ್ಬೋದು, ಏನೋ ಒಂದು ಎಲಿಮೆಂಟ್ ಟೂ ನಂಬರ್ಸ್ ಸಮ್ ಮಾಡಿದನು, ಅದನ್ನ ನಾನು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ತಾ ಇದೀನಿ. ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ತಾ ಏನಾಗತ್ತೆ ನೋಡ್ರಿ, ಫಸ್ಟ್ ಪೇರ್ ಐತಲ್ಲ a1 a2 a3 ಒಂದ್ ಕಡೆ ಬರೀಬಹುದು, ಇವು ಚೇಂಜ್ ಆಗಲ್ಲ. b1 b2 ಮತ್ತೆ b3 ಕಾಲಮ್ 2 ಮತ್ತೆ ಕಾಲಮ್ 3 ಸೇಮ್ ಆಸ್ ಇಸ್ ಇರುತ್ತದೆ. ಪ್ಲಸ್ ಅಗೈನ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ಆನ್ ನೆಕ್ಸ್ಟ್ ನಂಬರ್ಸ್ x y z, ಇದು ನಾನು ಈ ತರ ಬರೀತೀನಿ x y z, again b1 b2 b3 c1 c2 c3. So this is the important property for solvation of the problems. Okay, actually they deleted these concepts in our NCERT this year, so that's why we can applying in competitive, this one very useful for JE concept also, So in any row or any column in a determinant of square matrix is expressed as the sum of the two numbers. We can split the two numbers, two determinant forms in the same order. Okay na? So first one identical or same proportional, that determinant value 0. Any row, any column having zeros, that value 0. So any determinant given, in the determinant any row or column is multiplied with any constant value, that number of times that matrix determinant is also increased, means resulted. Okay na? So next, here another one there, ma. Any one triangular matrix they given. Triangular matrix already I told, ma. 1, 2, 3, 0, 0, 0, 1, 2, 3, 0, 0, 0. Here 3 there. Now here numbers given 4, 6 given. But this is which type of matrix? This is the principal diagonal. Principal diagonal above elements are zeros, means that is the lower triangular matrix. At that time determinant of A, just we can multiply the principal diagonal elements. Answer 6. Okay na? Okay, calculation in beda. So lower given or upper given or triangular given, anyone they given, we can find out determinant, means just we can multiply the principal diagonal. A very important property, that A is equal to that A transpose, both are same. That of AB is equal to that A into that B bariboduma, illa that B into that A baribod. Okay na? So B into A value. So B into A value. So next, this one very important, very important for competitive exams. So determinant of K into N of order N. This can be written as K power N into that A. This is very important property. Here determinant of K into A is equal to K power N into A. N means what? Order of the given matrix. Order of the given matrix. Okay na? So determinant of Ka is equal to K power N into that A value. So these are the properties of the determinants. Next, so determinant properties over, determinant 2 by 2 over, 3 by 3 over, after then minor cofactors over. Next we can learn the properties of the determinants. Next we can learn here singular and non-singular, two definitions there, matrix on determinants. Singular matrix, singular matrix. So singular is nothing but if any matrix given, the determinant value equal to 0, then matrix is said to be singular matrix. The determinant value equal to 0, then matrix is said to be singular matrix. Non-singular, non-singular matrix. But non-singular matrix means determinant of any matrix is not equal to 0. Then that matrix is said to be non-singular matrix. When non-singular matrix given, then only inverse of the given matrix is exist. A inverse is exist. Otherwise, A inverse, in this case, A inverse is does not exist. A inverse does not exist. In this case, A inverse does not exist. A inverse what here does not exist. Here A inverse is exist. When the given matrix is singular matrix, then A inverse is exist. The given matrix is non-singular matrix. A inverse is exist. Singular means inverse does not exist. Okay na? A is singular matrix. A transpose is also singular matrix. Some conditions there. Then so this is the singular and non-singular concept. So after then we can applying the very important adjoint of a matrix. But this is also very important for JE and K set. Okay, now adjoint of a matrix, adjoint of a matrix, adjoint of a matrix. But simply we can define adjoint ADJ, adjoint of A. We can define simply ADGA, adjoint of matrix is nothing but transpose of the cofactor matrix. Already we know that cofactors, transpose of the cofactor matrix is called a adjoint of a matrix. For example, I given example for 2 by 2 given and 3 by 3 given. So what we done see here, A is equal to 1, 2, 3, 4 numbers there. Okay na? Now we can find out first that adjoint of a cofactor. Cofactor matrix of A is equal to, for 2 by 2 simply we remember cofactor is nothing but, so cofactor of a matrix, cofactor of a matrix. First we can multiply it minus with minus 1 whole power ij. What is 1 minor? 4 value. So then 2 minor is 3 value, 3 minor is 2 value. So here 1 minor is 4 minor is 1 value. Now cofactor means this position is 1 1. So this position odd number, this value multiplied with minus, this one odd means this one. So this is the cofactor matrix. Cofactor matrix. Now adjoint A. Adjoint of A is equal to transpose of cofactor matrix. 4 minus 3 minus 2 1. This transpose can be how to write here? 4 minus 3 minus 2 1. So this is the cofactor matrix of 2 by 2. Now this transpose is called adjoint. Otherwise, simply we remember 2 by 2 matrix whenever they given, 2 by 2 matrix whenever they given, simply we remember how to find it. Adjoint means just we can interchange this diagonal, principal diagonal element. 1 ಜಾಗದಲ್ಲಿ 4 ಬರೀರಿ, 4 ಜಾಗದಲ್ಲಿ 1 ಮಾರ್ಕ್, ಅವೆರಡನ್ನು ಇಂಟರ್ಚೇಂಜ್ ಮಾಡಿ ನೋಡ್ರಿ. 4 1 ಅಂತ. ಆಮೇಲೆ ಈ ನಾನ್ ಡಯಾಗೋನಲ್ ಐತಲ್ಲಮ್ಮ, ಅದನ್ನ ಏನ್ ಚೇಂಜ್ ಮಾಡಬೇಡ್ರಿ, ಡೈರೆಕ್ಟ್ ಏನ್ ಬರೀತಾರೆ ನೀವು? ಮೈನಸ್ ಮೈನಸ್ ಅನ್ಬೇಡಿ. ದಟ್ ಈಸ್ ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ ಎ. ದಟ್ ಈಸ್ ಅದೇ. ಇವೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಬೇಡ ನಮ್ಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ. ಸೊ ನಾನು ಇವಾಗ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಬಿ ಸಿ ಡಿ. ನಮ್ಗೆ ಇದಕ್ಕೆ ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ ಬಿ ಬೇಕು. ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ ಬಿ ಬೇಕು ನಮ್ಗೆ. ನಾನೇನ್ ಹೇಳಿದ ನೋಡ್ರಿ, ಇವಾಗ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಇಂಟರ್ಚೇಂಜ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ ಡಿ ಜಾಗದಲ್ಲಿ ಎ ಜಾಗದಲ್ಲಿ ಡಿ, ಸಾರಿ ಎ ಜಾಗದಲ್ಲಿ ಡಿ ಜಾಗದಲ್ಲಿ ಎ ಬರಿಬೇಕು, ಆಯ್ತಾ? ಆಮೇಲೆ ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ ಸಿಂಬಲ್ಸ್ ಚೇಂಜ್ ಮಾಡಬೇಕು. ಮೈನಸ್ ಬಿ ಮೈನಸ್ ಸಿ, ಮುಗೀತು. ದಟ್ ಈಸ್ ದ ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ ಬಿ ಫಾರ್ 2 by 2 ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಏನಮ್ಮ? 2 by 2 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ ಎ ಆಗುತ್ತೆ. ಇಲ್ಲ ಅಂದ್ರೆ ಈ ತರ ಮಾಡ್ಬೇಕು, ಕೋ ಫ್ಯಾಕ್ಟರ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಮತ್ತೆ ಅದನ್ನ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಮಾಡ್ತಾ ಏನ್ ಬರ್ತದೆ? ಅಡ್ಜಾಯಿಂಟ್ ಎ ಬರ್ತದೆ. ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ನಾವೇನು ಅಂತ ನೋಡ್ರಿ, ಇದು ಕಂಪೇರ್ ಮಾಡಿ 4 1 ಇವೆರಡು ಇಂಟರ್ಚೇಂಜ್ ಆಯ್ತು, ಸಿಂಬಲ್ಸ್ ಚೇಂಜ್ ಮಾಡಿ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ 2 by 2 ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಬಟ್ ಸಮ್ ಟಿ ಬೈ ಟಿ, ಸಮ್ little bit there. Now given one example given, we can understand easily. So 1 2 3 4 5 minus 1 0 1 2 there. This is one 3 by 3 matrix. Now we can calculate adjoint of this matrix. Listen ma. So adjoint ಬೇಕಂದ್ರೆ ನಾನು cofactors ಇವೆಲ್ಲ ಬರೆಯಲ್ಲ. ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ನೀವು ಬೋರ್ಡ್ ಅಲ್ಲಿ ಬರೀತಾರೆ. ನಾನು ಏನ್ ಮಾಡ್ತಂದ್ರೆ ಸೆಕೆಂಡ್ ರೋ ಐತಲ್ಲಮ್ಮ, ಇದನ್ನ ತಗಂತೀನಿ. ನಾವು we can start second row. ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ 5 ಐತಾ, ಇದು ಬರೀತೀನಿ ನೋಡಮ್ಮ. ಸೆಕೆಂಡ್ ರೋ ಅಲ್ಲಿ ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟ್ 5 ಬರೆದು, ಆಮೇಲೆ ಮೈನಸ್ 1, ಈ ಕಡೆ ಎಷ್ಟಿದೆ ನಮ್ಮ? ಮೈನಸ್ 1 ಬರೀತೀನಿ. ಆಮೇಲೆ ಫಸ್ಟ್ ನೆಕ್ಸ್ಟ್ 4 ನೆಕ್ಸ್ಟ್ 5. ಅರ್ಧ ಆಯ್ತಾ? ರೋ 2 ಚೂಸ್ ಮಾಡಬೇಕು, ಮಿಡಿಲ್ ಅಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು, ಮಿಡಿಲ್ ಅಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ರೈಟ್ ಸೈಡ್ ಹೋಗ್ಬೇಕು, ಮತ್ತೆ ಲೆಫ್ಟ್ ಸೈಡ್ ಬರಬೇಕು, ಮತ್ತೆ ಅದೇ ಎಲಿಮೆಂಟ್ ಫಿಕ್ಸ್. ಆಮೇಲೆ ಥರ್ಡ್ ರೋಕ್ ಬರ್ತೀನಿ, 1 2 0 1. ಆಮೇಲೆ ಫಸ್ಟ್ ರೋಕ್ ಹೋಗ್ತಾನೆ, 2 3 1 2. ಇಲ್ಲಿ ಏನ್ ಬರ್ದಿದ್ರಲ್ಲ ಫಸ್ಟ್, ಮತ್ತೆ ಅದನ್ನು ರಿಪೀಟ್ ಮಾಡ್ರಿ. 5 minus 1 4 5 ಈ ತರ ಬರೀಬೇಕು. ಅರ್ಧ ಆಯ್ತಾ? ಫಸ್ಟ್ second row second element. After then we can come to the right side and we go to the left side. After then we can write on same third row, first row, and we repeat this one. But this is pattern for write on this one. Now directly adjoint if you want means what we done here. Directly if you want to find out adjoint of A, ನಮ್ಗೆ adjoint direct ಬೇಕು. So ಅವಾಗ ನಾನು ಏನ್ ಮಾಡ್ತೇನೆ, ಇಲ್ಲಿ 2 by 2 determinant values ಕಂಡಿಡ್ತೇನೆ. means this value how much? 10 minus half minus 1 ಅಂದ್ರೆ 11 ಆಗುತ್ತೆ. ಫಸ್ಟ್ ಇಲ್ಲಿ 11 ಬರೀತೀನಿ. ಆಮೇಲೆ ಈ ವ್ಯಾಲ್ಯೂ ಐತಲ್ಲಮ್ಮ 0 minus 8, ಆ ಮೈನಸ್ 8 ಇಲ್ಲಿ ಬರೀತೀನಿ. ನಾನು ಇಲ್ಲಿ ಬರೆಯಲ್ಲ, ರೋ ವೈಸ್ ಬರೆಯಲ್ಲ, ಕಾಲಮ್ ವೈಸ್ ಬರೀತೀನಿ. ಆಮೇಲೆ 4 minus 0 ಅಂದ್ರೆ 4 ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ 3 minus 4 minus 1, 2 minus 0 2, 0 minus 1 minus 1. So minus 2 minus 15, minus 2 minus 15 minus 17, 12 plus 1 13. Next 5 minus 8 minus 3. So this is the adjoint of the given matrix. This is adjoint of the given matrix. ಇದು ನೀವು ಬೋರ್ಡ್ ಅಲ್ಲಿ ಬರೀಬಹುದು, ಬಟ್ ಈ ಪ್ಯಾಟರ್ನ್ ಸಪರೇಟ್ ಆಗಿ ಬರೋದು, ಆ ಎಲಿಮೆಂಟ್ಸ್ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ದಿಸ್ ಇಸ್ A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay na? So this is the pattern for writing the adjoint of a 3 by 3 matrix. How to write an adjoint of 3 by 3 matrix means we can choose the first row and second row element we can write on second row second element we can write on right side and left side. ಅದೇ ತರ ಇದು ರಿಪೀಟ್ ಮಾಡಿ. ಅದೇ ನಮ್ಮ adjoint of a square matrix of 3 by 3. ಓಕೆನಾ? ಇದು ಇಂಪಾರ್ಟೆಂಟ್. ದೆನ್ ಪ್ರಾಪರ್ಟೀಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದು. ಪ್ರಾಪರ್ಟೀಸ್ ನಾನು ಹೇಳಿದ್ರಲ್ಲ JE ಕ್ವಶನ್ಸ್ ಇದ ಮೇಲೆ ಕೇಳ್ತಾ ಇರ್ತಾರೆ ಅವನು. A into adjoint of A or adjoint of A or adjoint of A or adjoint of A into capital A is equal to det A into IN. First property, det A into IN. ಆಮೇಲೆ determinant of adjoint A is equal to det A power n minus 1. ಇವೆಲ್ಲ ಪ್ರೂವ್ ಮಾಡಬಹುದು, ನೋ ಡೌಟ್. ಓಕೆನಾ. ನೆಕ್ಸ್ಟ್ another one adjoint of adjoint A. ಇದು ಮೇಲೆ JE ಕ್ವಶನ್ಸ್ ಇದೆ, ಬೇಕಂದ್ರೆ ನೋಡ್ರಿ ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರ ಅವನು. det A power n minus 2, det A power n minus 2. ಆಮೇಲೆ determinant of adjoint A is equal to det A power n minus 1 whole square. ಇಲ್ಲಿ 2 times adjoint ಬಂತಲ್ಲ, det A power. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಈ ಪ್ರಾಪರ್ಟಿ. ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ adjoint of and so on. adjoint of A r times ಎಷ್ಟು ಟೈಮ್ ರಿಪೀಟ್ ಆಯ್ತಮ್ಮ ಇದು? r times. ಇದಕ್ಕೆ ನಾನೇನ್ ಬರಿಬಹುದು ಇಲ್ಲಿ? det A power n minus 1 whole power r. ಎಷ್ಟು ಟೈಮ್ ರಿಪೀಟ್ ಆಗುತ್ತಲ್ಲ ಆ ನಂಬರ್ ಮೇಲೆ ಮಾಡ್ಬೇಕು. ಇಲ್ಲಿ 2 ಟೈಮ್ಸ್ ಆಯ್ತು n minus 1 whole square, 3 ಟೈಮ್ಸ್ ಆಯ್ತು 3. ಈ ತರ ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. det A determinant of adjoint A is equal det A power n minus 1, adjoint of adjoint A is equal det power n minus 2, determinant of adjoint A is equal det A power n minus 1 whole square. ಆಯ್ತಾ? Then another property this one also very very important. adjoint of K into A is equal to K power n minus 1 into adjoint A. K power n minus 1 into adjoint A. This is also very very important property, and this one also important, and this one also important properties. Okay na? So now this is the adjoint of K into K power n minus 1 into adjoint A. In so many properties are there. Adjoint of AB is equal to adjoint of B into adjoint A. Adjoint of AB is equal to adjoint of B into adjoint of A. Adjoint of A transpose. Adjoint of A transpose is equal to adjoint of A whole transpose. Adjoint of A power m is equal to adjoint A power m. ಆಮೇಲೆ adjoint of identity matrix. Adjoint of identity matrix. Adjoint of IN is equal to IN. Adjoint of null matrix is also null matrix. So these are the very very important properties for competitive exams. Adjoint of that A value, determinant of this value and this one, and this property. A is singular matrix, then adjoint of determinant of adjoint A equals 0. Determinant of adjoint A equals 0 when A is singular. A is singular, that implies determinant of adjoint A equal to 0. This is also another property. So now these properties are important for solving the questions. So tomorrow or there tomorrow if you solve number there, if you get these properties, and these are the very very important property for adjoint of a matrix. So what is adjoint of a matrix means the transpose of the cofactor matrix of the given matrix is called adjoint. 2 by T already told nama. Adjoint means just we can interchange the principal diagonal element, non-diagonal elements we can change the sign. That is adjoint. So 3 by 3 matrix means we can change row 2. First we can select row 2 and we can start the middle number and we can rotate the right to left and the third row and after then first row, and we can repeat the first one same. So that is the adjoint of 2 by 2 matrix and 3 by 3 matrix, and that is the properties of the adjoints. So after then here adjoints over means then invertible matrix, inverse of a matrix, inverse of a matrix. So inverse of a matrix is nothing but let capital A be a non-singular matrix, and we can choose one matrix A be a non-singular matrix of order n. Of order n, we can choose a non-singular matrix of order n, and there exists another same matrix of order same matrix B of order n, such that these two matrices product AB is equal to BA is equal to I. Any two matrices product is equal to identity matrix. At the time, each matrix are inverse to each other. Means AB is equal to I means B is equal to A inverse. B is called inverse of A. B is called inverse of A. So A is a non-singular. Already told them a non-singular means then only inverse is exist. Singular means inverse does not exist. A is non-singular matrix. That A is not equal to 0 at the time. Then we can choose another matrix of the same order such that AB is equal to BA. That value is equal to I. At the time AB is equal to BA is equal to I means B is called inverse of the given matrix. Okay, na? Now means any two number matrices product is equal to I. That matrix is said to be inverse to each other. But here properties A inverse whole inverse is equal to A value. One matrix inverse ಮಾಡಿ ಮತ್ತೆ inverse apply ಮಾಡಿನ ಅದೇ same matrix ಬರುತ್ತದೆ. Next AB whole inverse is equal to B inverse into A inverse ಉಲ್ಟಾ ಆಗ್ಬೇಕು B inverse into A inverse. AB whole inverse is equal to B inverse into A inverse. Then this value A transpose whole inverse is equal to A inverse whole transpose. A inverse whole transpose. Adjoint of A inverse is equal to adjoint A whole inverse. Adjoint A whole inverse. Adjoint of A inverse is equal to adjoint A whole inverse. So this one det A inverse is equal to 1 by det A is equal to det A whole inverse. This is also important. And previous NCRT bit also this one det A whole inverse is equal to 1 by det A into det A inverse. Adjoint A inverse is equal to adjoint A whole inverse A transpose. Or this one means what we have done det A power A power m whole inverse is equal to A inverse whole power m value. So these are the properties on inverse matrices. These are the properties on what inverse matrices. Okay na. So in determinant concept we can learn these concepts. So determinant inverse process means we can apply this one. Then here important questions for case set they given. We can find out the 2 by 2 matrices inverse and 3 by 3 matrix inverse. How to calculate that inverse means? For example, we can choose one condition here, means one question. If A is equal to 3, 4, 5, 6, then find A inverse. N calculate ಮಾಡಬೇಕು A inverse. So one property there here. A inverse formula I forgot here. So we know that A inverse can be written as in that formula as adjoint A by det A. A inverse property what here? A inverse is equal to formula what? Adjoint A by det A. Adjoint A by det A. Now given matrix what here? A is equal to this matrix given A is equal to 3, 4, 5, 6. Now we can write on here that A is equal to what we write on Sima here? 3 into 6 minus 4 into 5. That value is equal to 18 minus 20. That value is equal to minus 2. That is the determinant. Now we can write on adjoint of A. Adjoint of A of 2 by 2 matrix. Just I told no, we can interchange the principal diagonal and we can change the sign of the non-principal diagonal. Minus 4, minus 5. Adjoint of A and det A. Now finally we can write on inverse of this matrix is equal to A inverse is equal to formula what adjoint A by det A. Det A means what here? Adjoint of means this matrix. So det A means 1 divided by minus 2 into adjoint A means 6 minus 4 minus 5 3. So this is the inverse of the matrix 2 by 2 matrix. Inverse of the matrix how much more? 2 by 2 matrix. First we can remember this formula. A inverse is equal to adjoint A by det A. After then we can calculate this value. A is equal to 3, 4, 5 given. Then we can calculate that A value. After then we can calculate adjoint A. Adjoint A means we can apply the shortcut means principal diagonal elements ulta madre. We interchange the principal diagonal element and we can change the sign of the non-principal diagonal element. Now we can write on A inverse is equal to adjoint A by det A. Adjoint A means as it is, by means a fraction 1 by 2. So this value. So this is the inverse of the 2 by 2 matrix, inverse of the 3 by 2 matrix. And similarly, inverse of 3 by 3 matrix also there. Inverse of 3 by 3 matrix. That is also very, very important. Then how to find it? Inverse of 3 by 3 matrix means, so 1, 2, 3, 3, 4, 5, 2, 1, 3. 213. Now this is the matrix. Now we can calculate inverse of this matrix. Before we can find out first det A value. In case of det A equal to 0 means inverse does not exist. There only we can write on that condition. So det A means what we write on here? 1 into determinant of this value. So what I told here, determinant of this value means we can write on here. 1 means that cofactor 4, 5, 1, 3. Directly write no problem. For your understanding purpose, again I can write this calculation. Here 3, 5. This value how much more? 3. Sorry. 3. Again this one 5. 3, 5. Next 2, 3. And this value 3 into 3, 4, 2, 1. Okay, na? So this is the determinant of A. First one we can choose 4, 5, 1, 3. 2 we can choose 3, 5, 2, 3. Next 3 we can choose 3, 4, 2, 1. Now we can calculate this value 1 into 12 minus 5 minus 2 into this value 9 minus 10 plus 3 into 3 minus 8. Then how much here value? Here 7 there plus 2 there plus here minus 15. 5 number 5 3s are 15. So this value 9 minus 15. How much this value is equal to 6? So 10 means 6 minus 6. Okay, na? So this value is not equal to 0. Then this inverse is exist. Okay, na? Inverse is exist. Then how to calculate this inverse? Adjoint matrix we want. So adjoint matrix we want means where we start the values here 4, second row 4, 5, 3, again 4. Next 1, 3, 2, 1. Next so 2, 3, 1, 2. Again we can repeat this value 4, 5, 3, 4. Okay, na? So first we can run like this. Then second row, second element 4, 5, 3, 4. 1, 3, 2, 1. Next 2, 3, 1, 2. And we can repeat this value. Above value there same we can repeat this one. Now we can find out here adjoint means directly we can write on adjoint of A is equal to, how to write on adjoint of A means this determinant 2 by 2 determinant 3 4s are 12, 12 minus 5 7. Here write on 7 value, and again we can take this 2, 10 minus 9 1 value, we can write on here 1. Okay, next we can take this value, these two difference. Which difference here? 3 into 1 and 3 into 1 and 8. 3 minus 8 minus 5. So we can write on vertically that value. So then that is directly adjoint given. Now we can here we can write on the value. Which difference this value? And we can take 3 minus 6. 3 minus 6 means minus 3. Now we can take 3 minus 6 again. 3 minus 6, 3 minus 6, again we can take minus 3. Now here Sima 4 minus 1 means 3 value. Now last 10 minus 12 minus 2. Next 9 minus 5 4 value. Next 4 minus 6 minus 2 value. So this is the adjoint of the 3 by 3 matrix. Adjoint of the 3 by 3 matrix. Now we can write on formula. A inverse is equal to 1 by det A. 1 by det A means how much here again? 1 divided by minus 6 into 7 minus 3 minus 2 1 minus 3 4 minus 5 3 minus 2 minus 5 3 minus 2. So this value is equal to 1 value, and this value is equal to 7 there. Here how much there? 7. This value is equal to 7. Okay, na? So this is the inverse of 3 by 3 matrix. Very, very important. For case set, so many times they given this type of questions given. So what we can do, find out this value means first we can find out the determinant of the value. So the determinant, so not equal to 0. The determinant value is not equal to 0, then only inverse is exist. After then this method we can apply, you can easily find out the adjoint of A. So how to find it adjoint of A means we can find out the second element in the second row 4 5 3 4 1 3 2 1 1 3 2 1 again 2 3 2 1 2 3 2 3 1 2 2 3 1 2. Okay na. Next here must same repeat the value and we can find out the difference of this matrices. Then if you are getting inverse of the 3 by 3 matrix, so they given 3 by 3 matrix and 2 by 2 matrix by using these conditions, and we can simplify the given conditions. Okay na. Sometimes I already told them adjoint properties I given. Suppose they given adjoint properties means A is equal to, for simply we can take here 2 3 4 5 given 2 3 4 5. So for example, if A is equal to 2 3 4 5, then find determinant of adjoint A. Determinant of adjoint A. So how to calculate determinant of adjoint A means, before we can find out det A value, 2 into 5 10, this value 12, that is equal to how much more? Minus 12. So we know that determinant of A property what here, determinant of adjoint A is equal to det A power n minus 1. Det A power n minus 1. Now we can write down det A power n minus 1 minus 2 whole power. My n means what? Order of a matrix. What is order of a matrix here? Order of A is equal to 2 there. Order of A is equal to 2 there. Now we can applying here 2 minus 1. So that value is equal to 1. So again answer is minus 2 value. Again answer is what here? Minus 2 value. When A is equal to this matrix given, then we can find out the adjoint of A. Suppose this one, first one, part 1. Otherwise part 2 they are given like this given. Determinant of 3A given. In that question only, A matrix given. Now we can calculate determinant of 3A. Then how to find it? We know that already property, one property there. Determinant of K into A is equal to K power n into det A. How K power n into det A value. So now by using this one, we can write on this value. Determinant of K. K means 3 value. Order means 2. 3 square into det A value. 3 square means value how much more? 9. Det A value how much more value? Minus 2. Then that value is equal to minus 18. Okay, na? That value is equal to how much more? Minus 18. So like that questions they given on adjoint of the matrices or inverse of the matrices 2 by 2 given. Now we can apply and we can simplify these questions by using that properties. Okay na? Right. So this is the concept in totally matrices and determinants. Today what we learn here, determinant means, just I recall that once again, that recall that concept. So determinant means what? The determinant of any square matrix. The determinant of any square matrix is a unique number. The determinant of any square matrix is a unique number, means any one number given. So that is called a determinant. So after then, determinant of 2 by 2 matrix means A, B, C, D elements given means AD minus BC. 1 into 4 minus 2 into 3 value. Determinant of singleton matrix is also a single, that number only. Determinant of 1 given. What is determinant of 1 means? A is equal to 1 there. What is determinant of 1 means? 1 only. Okay na? Next, minor and cofactor. Minor means what? In the given any matrix, so if you want to find out any number minor, if you want, mean that corresponding element row and column are we neglected. The remaining elements we can take one determinant form. That value is called the minor. So that minor is multiplied with the cofactor means minus 1 whole power I plus j. So that value is multiplied with I plus minus 1 whole power I plus j. Then the resulted value is called cofactor of the given matrix. Okay na? So then determinant of 3 by 3 matrix, what we told. So the determinant of 3 by 3 matrix means any row or any column number elements, sum of the product of any row or any column element multiplied their corresponding cofactors. Multiplied their corresponding cofactors. Then the resulted matrix, the corresponding cofactors. Okay na? Then that value is called the determinant of the given matrix. Or determinant you can, when we calculate any row or any column, sum of the product of one row elements multiplied with another row cofactors, and at the time the determinant value becomes a 0. The determinant value becomes how much more? 0 value. Okay na? Right. Next, they given questions properties. Already I told them properties in any determinant, two rows identically or same numbers there. At that time the determinant value equal to 0 value. Any determinant, any row or any column, all elements are zeros, then the determinant value is also 0. Okay na? Now we can multiply any row element with respect to k times, then the resulted matrix determinant value also increasing k times of the original matrix. K times of the original matrix. That is the properties of the determinant. That one what properties of a determinant. Next, we can learn the condition singular and non-singular. Already I told you, singular matrix means what? Determinant of the given matrix equal to 0. Then that matrix is said to be singular matrix. Determinant of the matrix is not equal to 0. That matrix is said to be non-singular matrix. Okay, na? So sometimes they given questions like this also given. Suppose for example, A is equal to one matrix they given here. A is equal to 1, 2, 4x, or they given like this. Here also x they given, here also value x they given, here value for example here value 9 given, here value 9, and A is a singular matrix. If A is equal to this one and A is a singular matrix, then find x value. A is singular, A is singular, then then x is equal to, then what we find out, then x is equal to dash, then x is equal to dash. Then how to calculate that x value means we can take singular matrix from det A equal to 0, det A equal to 0. Now determinant of x9 4x, this value equal to 0. Then what we have to here, x into x is equal to x square, that is the minus this value how much here, 4 into 9 is equal to 36, that is equal to 0. X square is equal to 36, then x is equal to plus or minus 6. Okay na? So these are the questions for singular and singular questions given. Any one matrix given, we can find out the given matrix is singular, then we calculate the unknown variable of the given matrix, then we can applying this method and we can solving that given questions. Okay na? After then they given some type of this type of questions given. A is equal to 1 2 3 some k given, then a square minus 4a plus 10i is equal to a given, then find k value, then find k. But this one very important. Actually, how to solving this one? This equation, if you want to solve, means this is a square minus 5a plus 10i equal to 0. A square minus 5a plus 10i equal to 0. Here A matrix given 1 2 3 4 given, 1 2 3k given, then we calculate a square minus 4a plus 10i value. Okay na? Now we can find out the k value. So generally what we can apply here, A matrix there means we can calculate the A value and we can lengthy process. So except that lengthy process, we can apply here one method there. Whenever 2 by 2 matrix given, we can write down here a square minus trace of a matrix into A plus that A into I equal to 0. So this one we remember, this is actually called a characteristic type of equation. A square minus transpose of A into A plus det A into 0. So now already we know that this A matrix given means what is the transpose of A? Transpose of A is equal to 1 plus k value. Transpose means what? No? Principal diagonal elements. Transpose of A is equal to 1 plus k, and det A is equal to what? Here k minus 6 value. This value how much more? K minus 6. Now these values we can replace here. Then what would I see here? A square minus transpose of A means 1 plus k into A plus that A means k minus 6 into I is equal to 0. Now we comparing these two equations. Now we comparing A square minus 5A plus 10I is equal to A square minus half 1 plus k into A plus k minus 6 equal into I equal to 0. We comparing these two I. Here Sima A coefficient minus half this one, this value also minus half 5A. Then what would have done here? Minus half 1 plus k is equal to minus 5. Both becomes a positive. K is equal to how much more? 4 value. K is equal to 4 value. Or k minus 6 is equal to 10. K minus 6 is equal to 10. Then also we can consider that a value. So, but actually here plus, we can take plus value means then if you are getting that same value. So this is the process for this one. We remember this one. This is the process for this one. Whenever this type of questions, if you want, then we can calculate this method. what we applying the method? A square minus the transpose of A into A plus det A into I equal to 0 value. Okay na? So if you are getting this one for using this equation of the characteristic equation of the given condition. Hmm? So okay ma. So next class we will discuss that given concept, which concept they given, that problems there, matrices and determinants, that models also we can explain the in the next class or next sessions. Okay na? Right. Thank you.